Hello, my name is Nina Stangland. I'm the Managing Director of NCE Seafood Innovation. We are a business cluster with the different stakeholders in the seafood industry where we work together to contribute to sustainable growth and development of the seafood industry by focusing on innovation. In this podcast series of 5, together with LØRN and Seafood Innovation and AquaCloud, we try to share our knowledge and experience on the digitalization of the seafood industry. AquaCloud is a seafood industry project where we gather different farmers in the Norwegian aquaculture industry to collect data from different locations with the aim to contribute to more insights about the Norwegian aquaculture industry. And we hope to contribute to innovation, better fish health and fish welfare in the Norwegian aquaculture, and also contribute to sustainable growth and development of the industry. Enjoy your learning and enjoy our experience in elaborating this project in this podcast series.
Hello and welcome to a LØRN podcast in collaboration with NCE Seafood Innovation. My name is Silvija and my guests today are Trond Kathenes and Jørn Torsvik. Hello.
Thank you.
Hello.
Both your names sound very easy in Norwegian, and then I got a complete tongue twist when I was trying to say them in English. But I'm going to say just a few words about the series, and then I'm going to ask you to introduce yourself and your goals with your project. So LØRN is doing a series with the Norwegian cluster called NCE Seafood Innovation, which is a national cluster for companies that collaborate in aquaculture, which is salmon farming. And it's Norway's second largest export product or industry with 1.1 million tons of salmon being exported every year. So you guys are handling values and growth just as important and perhaps more environmentally friendly than our largest industry, which is energy and oil. So we are going to talk about digitalization in your industry with specific focus on a product called AquaCloud, which is a data platform related to the production data in your industry. And this is the first out of 6 conversations related to this platform. So with that, I'm hoping that you two could tell us just a few words about who you are and what makes you unique. Maybe we start with Trond.
Yeah, I'm Trond Kathenes. I'm the Chief Digital Officer in Grieg Seafood, and then obviously responsible for the digital initiatives and strategies that we are running in the company. And one of the main activities we started up with around the digitalization was the AquaCloud initiatives, ensuring that a number of companies gathered or collected the data, sharing the data into AquaCloud. For first of all, the goal of actually being able to predict the lice exposure towards our operational units as such. So that's a quick runner. But Jørn, you can go ahead with who you are.
Yeah. Well, I'm Jørn Torsvik. I'm the general manager of AquaCloud, which is this initiative we're going to be talking about, I guess. I ended up in aquaculture a couple of years ago after working many years in financial services, so also in digitalization. And it was really interesting to join this industry, which is so completely different from banking, where there's just, zeros and ones and everything is virtual. And here there's a lot of physical equipment, there is living creatures in these cages in the sea that you need to take care of, and the risk and the considerations are completely different.
I thought that you said a little bit more about who you are than Trond said. Trond, you were a Navy officer before.
Yeah, that's correct. So kind of a strange background, even more strange that Jørn's actually into the industry. But Well, being educated in the Naval Academy, I went in a military career, being commanding officer on coastal corvettes and so on. And then at a certain point in career, I started in projects, big purchasing projects, and then it's involved into the IT industry and how to utilize data to actually get more out of the tools that we gained. And that's where actually the interest for the technology really took off. And from there on, I jumped out of the Navy and joined the IBM, Capgemini, and the different numbers of big company within the IT management area. And then with some crossovers and back and forth, I ended up in this industry 10 years ago. And it has been a tremendous journey, actually, both in the company I work in, but also in the industry as such, being a part of the development and the early stages towards digitalization, and now there is a growing maturity into what we're into, and we continually open up eyes for our colleagues out at the sites and so on. So it's a really, really exciting journey.
It's a very, very important industry for Norway, and perhaps also one of the industries where Norway has a unique advantage in the world, both geographically, climate-wise, environmentally in other ways, and historically, culturally. So it's nice to be working with something that we really know exceptionally well. I'm just curious, because you both come from different industries. You've ended up in this cross-section of fisheries, or in this case aquaculture, which I've just learned from you before we started the podcast is a subset of the fisheries industry, which I'll ask you to explain. But you also focus very much on digitalization, and I would like you to tell us a little bit about the history of the project AquaCloud. So if we start a little bit with defining the industry, and then tell us about what's this project about. Maybe you start with Trond again.
If we go in from the top, as you indicate, it's the fishery. This is the part of obviously what we get out of the sea. But the fishery is then divided into the traditional fishery, and it is then the aquaculture, which actually is breeding salmon and trout in controlled environments at sea, and even also partly ashore. And the industry as such has come very far away when it comes to being efficient in production and so on. But still, to be able and to be allowed to grow, we need to get control over some of our biggest challenges when it comes to the environmental impact, the sea lice exposure, and so on. And then a number of the players in the industry gathered to actually see how can we now utilize technology and data acquisition to get a better understanding of what's happening in the water column in our pens. And how can we collect data and share data to see how we can utilize and find out, based on the big data sets, that there are something in the water column that we can help us to predict how exposed the fish is at any given time to lice or other species or organisms that is impacting the fish health and welfare in the cage. So that was the very start of the project, that there was a focus on the lice issue as such. And the gathering of all this data also opened up for more opportunities to find even more, and that's where we have gained in the different companies today also, gaining experience from the AquaCloud, and then take some of the knowledge back to our own companies and working even more into deep analysis on our own data set as such. So what we actually have seen now is just the beginning of our industry to work closer together with the offspring for AquaCloud, and how we're sharing data in a totally new way to learn the most of as much as possible of what's going on down in the water column in the pen.
Water column analysis, I think, is a really interesting image. And I'm going to let Jørn follow up on your comment, but I just want to give you one kind of personal side note. We did a series here in LØRN with innovators in Bodø. And one of the parties that we spoke with is a family-owned fish farmer, I think at Indre Karmøy, if I'm not mistaken. And I remember their description of, so basically they export most of their produce to a particular customer in America, buys everything, and their conversation with the board of this customer and their confusion and shock when they saw the level of infrastructure that we have in Norway, 5G and Internet of Things and full bandwidth broadband far out in the sea. And it's really interesting for us all to learn what can this be used for to make efficiencies in production, but also, as you said, sustainable growth. So I'm looking forward to hear more examples when we get there. But Jørn, where do you come into this story?
Yeah, that's a good question. I've been working with all the years I've been in aquaculture. I've been working with digitalization. First, I worked for one of the large equipment vendors and software vendors to the industry, and now I work for AquaCloud as well. And I think it's this point in time is essentially really exciting to be in the industry, because I see the last 2-3 years the digitalization rate and the digital maturity of the industry has really gained speed, gained traction. I think when these really visionary companies like Grieg Seafood and others came together 5 years ago to initiate the AquaCloud project, that was quite a big leap to take, because big data was the really hot buzzword that year, and coming together to collaborate and share the data was really something. At this level, it was something completely new. Of course, there have been initiatives before. There is governmental reporting going in through Altinn and those kind of things, but coming together voluntarily as companies to share the data openly to solve common challenges in the sustainability area is really an exciting initiative. And we follow up on that. We moved on from the lice prediction algorithms, but still the core data platform is at heart, and we also have different other initiatives to support that data platform in terms of data quality.
So I have to admit, I used to joke a little bit about some of the projects related to artificial intelligence applied to fisheries or aquaculture. When I remember a couple of years ago, there was an award to the most innovative organization or startup in Trondheim, Deep Tech. And I think the prize was given to a company that did some sort of a very smart image recognition and could recognize individual salmons, measure their size, make conclusions on whether the size is legal or either whether it was fishing or whether it was. And I know of many other projects where people optimize the amount of food being given to the fish based on the dynamics of the fish, and they can also find out whether the fish is stressed or not and relate the psychological health of the fish to the environmental conditions that they thrive in. So in some ways, I'm wondering if we've been actually better at digitalizing fish health than digitalizing human health in this country.
We have come a long way with the digitalization of the fish health. I'm not that sure that we actually are ahead of the human, but that's somebody else needs to answer that one. But I can tell you that all of the tools or the mechanisms that you're listing here, the image recognition, the analysis of the fish behavior and pellet recognition, the throughput of the pellet when you're feeding the fish, and all these aspects are things that already is put into use in our production in Grieg Seafood, for instance, and other players in the industry as well. So yes, we're taking advantage of all these kind of startups and inviting them in to help us to kind of gain results and also gain more maturity in the organization, to get the organization to understand the benefit and the possibilities of taking these kind of tools and technology into use.
I just want to understand a little bit better the basic problems. So you talked about lice infections, and so I think most of us just can't imagine really what's going on in a fish farm. You know, I see a circle on the surface. I don't know how far down I should think. I don't know how big. I don't know, you know, what's the process of dealing with that kind of an animal. And I understand also that given the pressure of having many fish together, there is a bigger exposure to disease. And then we need to make sure that we treat fish just as kindly as we treat animals on land. So we're trying to solve this problem. But please teach me a little bit about how does a fish farm work, if we start there?
Yeah. I take this one then, Jørn, okay?
Okay, go. Be my guest.
Yeah. Well, first of all, the fish farm is obviously what you see on the surface is the rings. And then it's all about the underwater conditions, the topography beneath the sea level. That actually gives the size and the depth of the fish as such, or the farm as such. So it can be between 50 and 75 meters deep. But the most vital thing, and it could be up to 200 meters in diameter, 160 to 200 meters in diameter. But the most vital thing is you're only allowed to have 2.5% of biomass or fish in the total volume inside the cage. So it's 97.5% water. And that's the maximum you can have, or the 2.5 of fish is the maximum you can have. And this is actually things that we are working very hard to actually keep track of, and obviously. But over the years, there has been limited possibility to understand the whole complexity of the water column in the pen. And that's where the new technology comes in, where the new data collection comes in. And also together with the scientists and the different organizations in research and so on, we are looking into what is the current condition in that specific pen, and what does the different micro mechanisms that is in the pen, how does that influence the fish and the fish welfare, and the fish are happy fish. A happy fish is a good fish, right? And can we foresee the potential negative exposure by seeing changes in the conditions in the water column? Then we might be able to put in some precautions to foresee that the fish still has a high welfare as it is. So it's all about understanding the details in the water column here. Yeah.
I'm just going to try to regurgitate this a little bit, just to make sure that I've understood it. So there are these water columns going 50 to 75 meters below. They can be 100 to 200 meters in diameter. And the rule is you can't have more than 2.5% fish within one column like that. There are some other variables I'm not quite sure about. So there is a mesh of some sort that's enclosing this that allows more or less water to pass. Or, I mean, yes, how much is the dynamics of the external conditions and the internal conditions in a column like this?
It depends on the surroundings and the sea current in the specific position that you are allowed to put your farm into, right? And then obviously there is a mask width on the pens that you also is, as the fish grow, the pen size goes up, so that you have enough throughput of water through the pen, so that the fish can get all the nutrition it gets from the surroundings water as well.
Can I ask you one more dummy question? Do you actually move the fish from one pen to the other when they reach a certain size, or they live their whole life within one pen?
Normally, they live their whole life in one pen. We change the net as it grows.
Right.
So
then my final question is, so then there is the variable of food, and I guess the weather conditions are reasonably stable. Maybe that's one of the advantages of Norway, of having both Gulf Stream and relatively cold water and lots of it. And then by optimizing what, do you make sure that the fish is as happy as possible? How do you keep them happy?
Yeah, that's the big thing, right? Because through understanding by identifying the different micromechanisms, the amount of them in the water column again, then you can actually see in the data set different markers and how the markers influence each other to then create good conditions or negative conditions. So if you're getting negative conditions, there obviously in some areas you can do something. In other words, you have to kind of protect the fish in other measures. For instance, if there is an algae blooming in the top layer of the sea, you stop feeding the fish, and the fish goes down and stay down since there are no feed coming. And then when the algae is drifting past and away from the location, then you start feeding again. So that's one example of what you can do in these. But other matters, you can put in some lice nets, as we call it, or it's actually a carpet in a way around the pen, which is about beneath the lice layer, because the lice is then from, let's say, 5 to 1 to 0 meters. That's where the main concentration of the lice is. And then you put some carpet around the pen, or presenning as we call it in Norwegian. Then the lice will then not come into the pen. And then obviously the fish is not exposed. So there are a number of measures that we can add into the scenario.
So I think no, the question to you, sorry, and I'll let you finish what you wanted to finish, but I also want to shoot in a question. How do you convert this good farmer sense into data?
Yeah, that's really interesting. Let me get back to that. I just wanted to comment that one of the tricky things is to balance these measures, because you want to keep the lice out, so you put in these carpets. But then again, you also want the fish to have sufficient oxygen levels, for example, which these carpets limits, because they limit the flow through of fresh oxygenated water. So you really need to balance, and then to balance and do the right message, you need data. You need input from your sensors, and what you need to know what's happening in the water.
And these sensors, help me imagine them. So they measure what?
Yeah, when they measure, the sensors we had for a really long time is about some of the basic environmental conditions. So we mentioned oxygen, it's definitely important. Salinity is another. Temperature as well. Temperature is probably one of the most important factors impacting the growth of the fish. So you want to know about that. What's happening now is that we gain more and more sensors measuring different things, and we were talking about the computer vision stuff some minutes ago, and that's basically also just a sensor giving us more information about what's going on in the pens. So fish behavior, we're detecting pellets, if they're falling through the fish layer, so the fish has stopped eating. Of course, that has impact both on operational efficiency because feed is expensive, but also on the environment because the pellets are falling through and they're going to the bottom and they're being eaten by different species that not supposed to have the fat the feed of the salmon. So being able to measure the fish appetite and feed accurately is really good for business, and it's also really good for environment. So it's a win-win case.
And then you connect this to the production numbers, which are what?
Yeah, well, production numbers are basically what we were talking about, but it's also a lot about the inventory. So you have the number of fish you put in a pen. You have the estimated growth of that fish. So you have an estimate of the complete biomass in your cage at any point in time. With the computer vision, that might change because we will get a more accurate reading of the actual size and weight of the fish. So instead of using a model over almost 2 years of salmon growth, we can actually do accurate readings of their current size, which is good. So that's an important production data. Of course, we record along with that the conditions they live in at every point in time. Okay, yes, environmental conditions. I'm sorry. So yeah, and there is information regarding fish health. So diseases, vaccines. We collect mortality, the reasons of mortality. Why do the fish die? Are fish removed for specific causes when they are sent to harvest? Because when they end their life, they're supposed to be food. So we record that. We record what feed they received throughout their lifetime. So basically, when the fish is going to harvest, you can take out more or less the fish CV. And you can read all what happened through the fish since it basically hatched and went into the sea.
Can I just go back to one question? I'm just fascinated by the relevance of fish lice. Can you just help me understand? Is a fish that's lice infected doomed to death, or is it just not going to thrive very much? Can we eat it? How in what sense does lice affect the fish?
It affects it that it's unpleasant to start with. It's unpleasant to have it on the skin of the salmon. You can see it doesn't actually feel well, right? And to a certain amount, and then if you've got too much lice on it, that fish, it starts also eating the skin of the fish as well, and then you got wound on the fish, and then that's not the scenario you want to get at all. So it's very important actually to try to avoid that the lice is actually thriving or setting down into the pen. Yeah.
And how do you medicate to get rid of it, or do you blow some air through the thing, or do you run a huge stream through the fish, or what do you do?
There are different measures.
Yeah, come on,
Okay, there are different measures to handle it. Previously, medications were used a lot, but more and more the lice has gone resistant to the most commonly used medications. So new measures has been invented, typically mechanical delicing. So we take the fish out of the sea and we use warm water to paralyze the lice so it falls off. It can be with the semi-high pressure water, it can be flushed off. We have brushes, so nice little brushes to brushes the lice off the fish. So that's used very much. Of course, there are the more fancy stuff. More recently developed is the lice laser. shooting. And which company has developed this that shoots laser beams and actually kills the lice falling off the fish. So there are different measures, but yeah.
From fish spa to fish laser, so lice lasers, it's actually an incredible world out there.
Yeah, and of course we also we need to mention the really analog measures, which are the cleaner fish. Which is put in the pens as a really early stage measure to they eat the lice off the salmon.
So now we go back to AquaCloud. So we have this data about the size of the fish and the number of the fish and the oxygenation of the water and the temperature and everything. And as we correlate this data, we can figure out if there is an even better way to bring up the fish. Is that the goal? Or you told me that your goal is sustainable growth. What does that mean?
Yeah, you want to take this, Tom?
Yeah, okay, that's easy. The aim is actually to again build up the total knowledge of what's going on, what influences the fish as such. One thing is in the freshwater stage of the fish, which is actually the first 18 months of the growth of the life cycle of the fish, and then it comes to sea. In the freshwater at land, then you have good control in the facilities that we are using, and then it comes to sea. Then it is more an open question to what is actually coming through the water to influence. So by adding sensors and building up the knowledge, building up the data sets to see the markers and identify the markers as early as possible, then you can actually understand the fish in much better way and how the fish behave based on the current condition in the pen as such. And that's what we are striving for. That's what we are using the machine learning. That's what we are adding all the algorithms so that we can understand the fish the outermost, so we can be as early as possible to try to give the fish the best possible way of living. It's easy as that, but as complex as that.
So thinking about sustainable growth, it is really a big term, because growth is about really a significant growth of the industry, because there is a goal of producing 5 million tons of salmon in 2050, which is tripling or so of the current production rate. So to get there, we need to do a lot of things. We need to keep salmon competitive, in terms of producing it efficiently, so the price per kilo is competitive against other sources of animal protein. It needs to be attractive to customers, so it needs to be, customers are more and more environmentally conscious, so it needs to be tracked and proved that it's been brought up in an environmentally good way. And it's produced in a licensed environment. So you need licenses to produce salmon, and there are conditions to that to, for instance, protect the environment. So limitations of handing out new licenses, it depends on solving some of the issues, like, for example, the sea lice problem, which is a huge limitation today, because the total impact in the area on the wild salmon population is really impacted by the density of new farms. So we need to fix that if we're going to get more licenses, and all this brings together. It's being attractive to customers, being within government regulations, and actually producing in a sensible, business sensible way. All of this works hand in hand.
Yeah, and everything is also interconnected as such as well, right? So we need to. One thing is that we need to be sustainable in everything what we do, but at the same time we also need to ensure that our provider, our feed provider, for instance, actually are producing in a sustainable way themselves as well. So there are no soya in the feed, and there are no child workers involved in the production, and all these aspects to it. So that's the total picture of sustainability is vital for us as an industry. Same as when we take the fish from the farm to the customer. How do we do that in the most environmental positive way as well as such? So there are many elements to it, and everything is then interconnected.
Sorry.
Yeah, yeah. I don't think we really, at least not in AquaCloud, we have all the answers on how to handle this. But what we do now is that access to high quality comparable data is vital to understand this going forward. So that's why our focus now is after we took the learnings we did from the sea lice prediction projects we did a couple of years ago, and we use that knowledge to see, okay, where can we contribute as a platform, and that is to provide data to help the standardization, so that the data is more comparable and standard across different providers, and we make that data available to research institutes, to entrepreneurs and startups, or farmers themselves, anyone who have great ideas, who have great knowledge and insight, that can use data to give these answers back to the industry. So we don't have the answers. We probably not have all the questions even, but we try to provide that infrastructure to let other stakeholders focus on their core idea or value proposition.
So what we really want to do, I was just going to add that what we are on a mission here is partly to build a data culture in the space of aquaculture, where the more people in your cluster, in your NCE Seafood greater environment, agree to be a part of this data producing society, the better we will be able to understand our happy fish.
Absolutely. And there is an add-on to that as well. One thing is to collect the data, and another thing is to share them, and actually work together while sharing, work together with analyzing the data, test each other's algorithms and models for analysis, and how you approach a challenge, and work across the companies in the industry. That's the next level that we are already started. And that's the benefit of AquaCloud, is actually the culture of sharing, the culture of sitting together and gain insight to the data that will benefit the industry as such, not only the individual companies, but the industry.
I have to make a comment for our international audience here. And it is to do with Norwegian public sector platforms for data. And we have one of the best platforms in the world in something called Altinn, which is all public tax-related financial data flows and related to individuals. And it's a super interesting collaboration between our banks, our tax authorities, our regulatory authorities, our administrative authorities. And I'm wondering if you guys are actually making an Altinn for fish.
Yeah, well, to some extent, yes, and on the other hand, absolutely not, because this is a voluntary effort by companies who want to come together and who want to share, which typically means that we have more velocity because there are no regulations involved, so we can act sooner. We can adapt our data, structures and contents, and what we do with it more rapidly. So I think we have, of course, some challenges because we cannot mandate to get all the data, but we have some advantages in terms of what we can do and how fast we can do that.
You can avoid some of the politics of our electronic patient journals.
Yeah.
But I think it's a really interesting point that you're talking about velocity, because so here we have Jørn from the cluster and the kind of the platform owner, and we have Trond, who's one of the most ambitious users of this platform, and perhaps also one of the one of the earliest, both developers and users. So Norwegian fish farming is not necessarily like all other kind of fish farming. I know there are other countries that have basically over-farmed, and therefore, they have an irreversible lice problem, perhaps. So what you're trying to do here is grow from 1.1 million tons to 5 million tons, but in a way that works with the nature. Is that kind of correctly summarized?
That's correctly summarized, and obviously that is also the clear statement for our government and the regulators as well. So this is something that we have a common goal on, definitely. Yeah.
So what's your ask to the people that are listening to this? I think in some ways you already said it, but you have some data, you'd like to have even more data, and you have good users and you'd like to have even more users. Is that the...
Yes, definitely. We really want as many as possible from the Norwegian salmon farmers to join the platform, to share the data, and to also get access to share data sets between each other. And we're talking with a lot of innovators and data consumers out there, but we're really happy to have more in that conversation.
Room for more. What do people need to do to join your data revolution?
Well, as a farmer, you can contact us during our website, aquacloud.ai, or if you are a consumer, we will shortly be releasing our developer portal where you can subscribe to data sets that we make available.
And you help people analyze as well. You don't need to have a master's degree in computer science to be able to do this?
Well, it will definitely help on the analytics side. We try not to go into the analysis. We work somewhat with our platform just to ensure the quality and try to see possible uses of the data. But how to connect and correlate and find those deep insights in the data, we leave that to our partners.
Trond and Jørn, as an outsider to your industry, I have to say it's been incredibly inspiring to talk to you. And I think for all of us Norwegians listening in on this, learning more about the real advantages and strengths of our second largest industry is a real necessity. So thank you so much for contributing here.
Thank you.
Thank you very much.